true strain versus engineering strain. So let's define this engineering strain. We represent this engineering strain with a small letter E, and it is nothing but the amount that a material deforms per unit length. The general definition, okay? So the amount which that a material deforms per unit length. So it could be either by tension or compression, increment, decrement, that totally depends. So I have not rather specified it whether it's tension or compression. It could be both. So it is basically the amount that a material deforms per unit length. And how to define this? The formula for this, mathematically we can write that E is equal to delta L by L naught, where L naught is the original length. Okay. Now how to define your true strain? We represent this true strain with epsilon. It is defined as the natural log of the quotient of the current length over the original length. So here we have delta L by L naught, and in this case we have epsilon is equal to delta L by LA. That is the only difference. So LA is your actual length and L naught is the original length. That is, what do you mean by original length? The length before the deformation has taken place. And LA means the length which is at the process of deformation or after the deformation or instantaneous. So another formula that you need to remember is epsilon is equal to ln L by L naught, the most important and most frequently asked formula. So in case of discrete, so let us consider we have some discrete elements. In that case, if you are summing up the strain, so in that case you can write epsilon is equal to summation of delta L by L. Now if you consider the thing to be continuous, so in place of summation we'll be having integration, and this continuous dl divided by L. So this you need to integrate it from L naught till L, that is from the original length till the length or the point at which you want the deformation. So if you integrate it, you will get ln L, and if you substitute the limits, you will get ln L minus ln L naught, and this we know that log A minus log B will be log A by B. So here we can write ln L by L naught. So another important relation, if you want to write the relation of a true strain in terms of length, you can use this relation. Or if you want to write the relation of this true strain in terms of area, you can write epsilon is equal to ln A naught by A. So this is another important relation and formula that you need to remember. Now let's see what is the relation between your true strain and engineering strain. So epsilon is equal to ln E plus 1. I'm suggesting you to please mug it up, this relation particularly. Okay, so the previous relation that we had discussed in the previous video of true stress and engineering stress, and the relation between true strain and engineering strain. So this is very important. So epsilon is equal to ln E plus 1. So here also I have shown it again. So please, I'll call these relations to be master relations, because so many times frequently in all exams they ask a question related to this true stress and true strain. So you need to mug these two relations up in order to avoid losing your score. So sigma is equal to S into E plus 1 and epsilon is equal to ln E plus 1. It's quite easier to remember. E plus 1 is common in both. So if there is sigma, there you need to write S. If there is epsilon, you need to write ln. Okay. So remember these two master relations of true stress and engineering stress, and true strain and engineering strain. See you in the next lecture. Till then, bye.